going to be covering the electromagnetic spectrum topic. I will be talking about the principles and properties of types of electromagnetic waves, the uses and hazards of X-rays in medical applications. I will also be explaining some appliance of visible and UV light and explaining the biohazards of ultraviolet and infrared radiation and what their effects are. Electromagnetic waves travel through a vacuum at a velocity of 300 million metres per second and can have a range of wavelengths and frequencies at different amplitudes. The human eye has evolved to detect a band of these wavelengths right in the middle of this range. This is the spectrum of visible light. They are transverse waves that travel at the speed of light. The spectrum of their wavelengths result in waves that are used in many of our useful devices. The waves are formed by heat, electronics and nuclear forces. Following are some examples of what uses electromagnetic waves. There's the TV, radio, microwaves, infrared, visible light, ultraviolet and X-rays. Imagine a rainbow when there is still rain in the air. The rainbow is formed because the light is bent or refracted. When it passes from air through water, but different wavelengths of light are refracted by different amounts. Here is an example of a refraction of light through a prism. So light comes in, and this is the light that comes out the other side, and as you can see, there are various different colours. The principles and properties of types of electromagnetic waves. We see different wavelengths as different colours. Red light has longer wavelength and lower frequency than blue light and is refracted by only a small amount. Blue light with a shorter wavelength and higher frequency is refracted more than red light, so the colours spread out. The wavelengths of electromagnetic radiation we cannot see begin with infrared and ultraviolet. Although we can't see them, we can still feel their effects, and these are as follows. Heat of infrared radiation coming off hot objects, damage of ultraviolet radiation such as sunburn, electricity and magnetism. So properties of waves. Firstly, take a look at the following diagram to understand the basic principles of electromagnetic waves. It shows the shape of a transverse wave and the measurements that can be taken. There are 4 properties of a wave, and these are velocity. This is the speed of a wave in a specific direction. Wavelength. This is the space between the waves. Frequency. This is the amount of waves. And amplitude. This is the measure of the amount of energy the wave is carrying. The wave equation. Velocity equals frequency times wavelength. The wave equation triangle is often used to solve equations. The 2 bottom values are multiplied to find V. Take a look at the diagram given to see this. What is infrared? Infrared is used in short-range control systems such as TV remotes. Infrared signal varies on how far it can travel depending on the strength of the transmitter. For infrared to be detected, there must be a direct line of sight between the transmitter and the receiver. If something gets in the way, the signal will be reflected, just like light. What is infrared used for? Objects such as an electric fire, heating element, or an electric cooker glows red when it is hot. This, however, is the invisible infrared radiation that is transferring energy as heat. Although we cannot see infrared radiation, we can use other sensors to measure it and display its intensity as a value. For example, a thermometer, or as an image such as produced by a thermal imaging system. Lower levels of radiation may not be felt as heat, but like all other forms of light, can be used to illuminate objects and the reflected rays detected by an appropriate sensor, such as a home security system. These incorporate a source of infrared light into a camera that detects wavelengths of light in the visible spectrum and into infrared. The uses and hazards of X-rays in medical applications. X-rays are a form of electromagnetic radiation with higher frequency waves that carry more energy and penetrate a lot further. As you can see on this diagram here, it shows you the longer but lower frequency, which is the visible light, and the X-rays, shorter wavelength, higher frequency, and there's a lot more there. Here are some points of uses and hazards of X-rays in medical application. Uses, they are used for examining broken bones, to check progress of tooth development. Patients are supplied with a lead-lined apron to protect them from unnecessary exposure, and a complete 3D scan of the body, such as a CT scan. The hazards, it can kill cells or trigger cancer cells. Professionals working with the machine on a regular basis run the risk of accumulated radiation dose through repeated exposure. So visible light prism. If the visible light spectrum passes through a prism, the resulting rainbow reveals all colours in the spectrum. These range from red with a wavelength of 700 nanometers through orange, yellow, green, blue and violet, which has a wavelength of 380 nanometers. These waves travel at 186,000 miles per second in a vacuum. This is referred to as 1 light second. Visible light is made of both waves and particles. Here are some applications of visible light. We have vehicular communication, so lane change and accident warnings, underwater communication, and vehicle-to-vehicle communication. Visible light is used to provide both lighting and information using VLC techniques. Properties and application of UV light. Ultraviolet light have shorter wavelengths than visible light. They are invisible to the human eye, however they can be seen by some insects and animals. Ultraviolet light can be used for a number of things, such as checking counterfeit notes, to disinfect surfaces. They are used in sunbeds to recreate the sun waves, and ultraviolet rays can be used to treat vitamin D deficiency. Biohazards of ultraviolet radiation and its effects. UV light is a high frequency of electromagnetic radiation which carries more energy than infrared and can penetrate further. UV light can cause chemical reactions to take place by breaking bonds in molecules. Our skin reacts to UV light by producing melanin. Too much exposure can penetrate into the human cells and can cause chemical changes in the DNA. A change in the body's DNA can result in mutating and cancerous cell development. So here we have a DNA before and here's after, and you can see the broken down part there. Infrared radiation biohazards. Infrared radiation is emitted from any hot object and will heat anything it strikes. Infrared radiation can cause superficial burns and blisters to the skin. Intense focused infrared light can also damage to parts of the eye. Protective goggles are given to patients receiving infrared treatment. This is over 1,000 times more powerful than a TV remote. I hope my presentation gives you more of an insight of the electromagnetic spectrum. Thank you.